finished? Hello?
No, ma'am, not yet.
Not yet.
हो गया मैम, हो गया.
Okay, okay. What was the topic for today's value added?
मैम अटेंड नहीं किया क्योंकि इनफ जगह नहीं थी उसके अंदर.
Okay, okay. ठीक है. So should I start lecture or is there anyone still there in that meeting?
मैम आप स्टार्ट कर दो ना.
Okay. Okay, today we'll discuss based on back propagation. तो यहाँ पे हमारा सेकंड मॉड्यूल कंप्लीट हो जाएगा. Then tomorrow onwards we'll start with the third module. Okay. So the back propagation model. This we have done XOR right last time on Monday, and today we'll see back propagation problems. Just write down this problem using back propagation network. Find the find the new weights for the net shown in the figure. Okay, so this is a network that is being shown and it is given in the book. It is presented with the input pattern 0 1. You can see what is the input here. It is 0 and 1. It is presented in the network as 0 and 1, and the target output, that is y, is equals to 1 आना चाहिए. So this is your target or the desired output. तो देखते हैं हम लोग को कौन सी वेट्स पे वी गेट दिस टारगेट आउटपुट y इक्वल्स टू 1. सो यूज द लर्निंग रेट अल्फा इक्वल्स टू 0.25 एंड बाइनरी सिग्मोइडल एक्टिवेशन फंक्शन हमको यूज करना है. ओके, सो बाइनरी सिग्मोइडल एक्टिवेशन फंक्शन आपको याद है? Okay, just write down this problem. Okay, try to understand this problem. What is given? The input that is 0 and 1 it's given, and target what we need to find, it's output y equals to 1. यहाँ पे weights given है already, that is minus 0.2. You can see 0.3 है, 0.4, 0.6. So it is having input layer, hidden layer as well as the output layer. यहाँ पे bias भी दिया है at the extreme right hand side. Can you see extreme right hand side? This is equal to 1 and 0.5 is the weight. It is going to Z2 hidden layer. Okay. So this is the complete network. Then have you completed writing this problem?
No, ma'am. 2 seconds.
No, ma'am.
हाँ हाँ हाँ. Write down. Okay. So this problem, what be the first step? हम लोग क्या करते हैं? हम लोग इनिशियल वेट्स डिफाइन करते हैं, बट यहाँ पे वेट्स इज ऑलरेडी गिवन, तो हमको देखना है द इनिशियल वेट फॉर सपोज this from network x1 to z1. What are the initial weight from x2 to z1? What are the initial weight that is presented to the hidden network, that is z1? ठीक है, तो हम लोग क्या करेंगे? V11, suppose V11. What is V11 is V11 is 0.6, right? The weights presented from X1 to Z1 is suppose V11 is equal to 0.6. Then V21 क्या होगा? It is minus 0.1, and V, this is bias network, that is B0. So it's V01. V01 is 0.3. So you need to write down the initial weight that is presented to the hidden network Z1. Then hidden network Z2 के लिए initial weights क्या है? That is, this is V01, this is V22, and this is V12, right? तो उसके लिए कौन कौन से आएंगे? V12, V12, V12 is 0.3, right? Then V22 is 0.4 and V02 is 0.5. Are you getting? Hello? Are you getting the initial weight that is presented to Z1 and Z2? And then हमारे जो weights है, suppose weights given to the output layer, we'll initialize at W0, W1 and W2. ठीक है, तो W0 के लिए it's -2, W1 के लिए 0.4 and W2 के लिए 0.1. ठीक है, so the weights given from hidden layer to output layer is W0, W1 and W2. So you can see from this that the initial weight, step 1 is what? Initial weights are V11, V21 and V01. हमने ऐसे वेक्टराइज फॉर्म में लिखा है V12, V22 and V02. It's -0.3, 0.4 and 0.5, and W1, W2, W0 is the weight from hidden layer to the output layer. So these are the weight and learning rate. It's given as alpha is 0.25 and activation function you need to use a binary sigmoidal function. That is f of x is equals to 1 upon 1 plus e raised to power minus x. तो ये इतना लिखो. Okay, done. So what will be the next step? Next step is to calculate the net input, right? So the net input हम लोग कहाँ से लेंगे? From the layer Z1. ठीक है, तो हम लोग क्या लेंगे? The net input going to the layer Z1. ठीक है, for this Z in one that is input from this input layer to Z1 is equal to हम लोग क्या लेते हैं? Bias B plus X1 V11 plus X2 V21, right? So you can write or to you can calculate the net input going to Z1 and the net input going to Z2. तो ये दो क्या रहेंगे? For Z1 layer and for Z2 layer, right? So can you calculate it? Net input as like this. V01 is your bias, then plus X1 V11 plus X2 V21, and for Z2 layer it's V02 plus X1 V12 plus X2 V22. This is your step 2. Write this. You can see this X1 and X2 is already given as an input sample, and the target is uh, y equals to 1, right? T equals to 1. Yes, done. Yes.
Yes, ma'am.
Okay. So what will be the next step? Is to apply the activation function. ठीक है, हमारे पास activation function कौन सा है? This is binary sigmoidal function. Then 1/1 plus e raised to power minus x, right? So f of x की जगह पर what it will be the function f of z in, right? So f of z in 1, f of z in 2. तो हमको क्या मिलेगा? z1 and z2. So write this step 3. Apply the activation function to calculate the output, that is Z1 and Z2. यहाँ पे क्या किया हमने? Z in 1 की वैल्यू डाली, that is 0.2, and Z in 2 की वैल्यू is 0.9. You will get this value. Okay, step 3. Now you need to calculate the net input entering the output layer. ठीक है, तो हमको नेक्स्ट स्टेप में क्या करना है? हमको ये निकालना है, the net input entering the output layer, that is y. So what will be the output layer y? Y in will be equals to the W0 weight, that is bias ka weight, plus Z1 W1 plus Z2 W2. Okay. So step 4 में you need to calculate the net input entering the output layer y. So it's y in equals to W0 plus Z1 W1 plus Z2 W2. And you need to apply the activation function to the output layer also. You apply the activation function, sigmoidal function, and you will get this y is equals to f of y in. Do this step 4. After completing, let me know.
Ma'am, wait.
Then
Ma'am, wait.
okay.
Yes, ma'am, done.
और कोई बाकी है? After this, we need to calculate or compute the error that is present in the back propagation. So error find out करने के लिए we need to give del k, or delta is the function. It's del tk minus yk into f dash of y in of k. So this, what is f dash of y in of k? It is f of y in into 1 minus f of y in. ठीक है, तो हम लोग f of y in की वैल्यू डाल देंगे जो इसके पहले हमने निकाला है एक्टिवेशन फंक्शन डाल के, and you will get f dash of y in k. And what is tk? Tk is equal to 1. So Tk is T1. T1 is, as the expected outcome is what? It is equal to 1. ठीक है, हम लोग जो expected y equals to 1 दिया हुआ है already, that is the target output. So Tk is what? T1. T1 is equal to 1, and yk is already we have calculated, it is 0.522, and f dash of y in of k. ये क्या निकल गया? This is the error portion, that is del k, error from input layer to the hidden layer. So this is the error portion. After this, we need to find what are the changes occurred between the hidden layer and the output layer when there is an this much of an error is there, that is delta 1. So find the changes in the weights between the hidden and the output layer. So the next step, you need to find the changes in the weight. तो हम लोग weight change के लिए जो delta of W1, delta of W2 and delta of W0 हम लोग निकालते थे. So it is equals to alpha into Z1, alpha into Z2, and alpha into this was your for the previous and or case जो होता था. Now in this case you need to multiply with this error also. So the weight changes is given by alpha delta 1 into Z1, alpha delta 2 into Z2, and alpha into delta 1. So these are the weight changes, delta of W1, delta of W2, and delta of W0. Write this down. Okay, and now after this, we need to find the error portion in both the hidden layers. So we need to calculate delta J. So J के लिए where J will be considered as for the first hidden layer and we'll consider J for the second hidden layer. So J will vary from 1 to 2. Okay, so it will be sorry. So delta J is equals to delta in J F dash of Z in of J. So delta in J is what? It's summation of delta K into W of JK. And J varies from 1 to 2 for the hidden layers and an input layer and between the hidden layer. So this will be the computing error between the input and the hidden layer. And delta K wala kya tha? The overall error in the network. So for the first input layer, only one output neuron is there. That is delta 1. So delta 1, only one output neuron is there. That's why it is we have calculated delta 1. So delta in 1 is equals to delta 1 into W11. Delta in 2 is equals to delta 1 into W21. ठीक है हमारे पास दो weights है. So for the first network and which is coming from the second hidden layer. So delta in 1 and delta in 2 for the first and second hidden layer, and delta 1 is common because there is only one output neuron. So delta 1 into W11 and W21. तो ये weights की value हमारे पास है already. So right till here. WhatsApp पे Okay, the next step after this, we need to find the errors, that is delta 1 and delta 2 for the both hidden layers. So it is delta in 1, f dash of z in 1, and delta in 2, f dash of z in 2. So f dash of z in हमने यही formula use करना है, but you need to calculate for z in 1 and z in 2, and then multiply for this delta 1 and delta 2. ये लिखो, इसमें कैलकुलेशन ही ज़्यादा है, ऐसा कुछ समझने लायक ज़्यादा कुछ नहीं है, जस्ट इट्स कैलकुलेशन. Okay, next step is the next two step are the final step. You need to find the changes in the weight between the input and hidden layer, and then the final net weights of the network. Okay, so the changes between the input and the hidden layer. Suppose it's delta V11. I'll show you the network. So delta V11 is what? It is this one. Weights of this network. अगर हम मुझे ये change of weights देखना है, it will be the learning rate alpha, it is 0.25 into delta 1. Delta 1 अभी हमने calculate किया है, and into x1. So x1 is what? It's 0. तो हमारा the delta v1 क्या होगा? The net change in the x11 and z11, that is v11 में क्या होगा? It is equal to 0, means there is no change. Similarly, find it for V21. So V21 के लिए क्या है? It's again alpha into delta 1 into, let's say, into minus 0.1. So आप ऐसा change करते रहो, you will get the value of delta V11, V21, V01 like this. This this changes in weight between the is delta V11. So it's alpha delta 1 into x1. So x1 हमारा यहाँ पे क्या है? 0 है, right? Alpha is equal to 0.25. Delta 1 हमने ये अभी निकाला है 0.0118, right? And into x1 हमारा क्या है? It's equal to 0, right? X1 and x2 is already given in your question. This one. Is 0 and 1. X2 is 1 and uh, 1 equal to 0. So हमको बस यहाँ पे सब करना है. ठीक है. Similarly for delta V2, delta V01, delta V22 and delta V02. तो ये लिखो यहाँ पे. Let me know after finishing this. बस एक इसके बाद एक last step बचता है to find out the final weights of the network. Okay, then after this, you just need to add the change in weight with the old weights, right? This is the final weight computation. So V11 old. So V11 old is the final, this one. Yes, this one. 0.6. V11, V21 is minus 0.1 and this is V01. तो ये सारे जो इनिशियल वेट्स है हमको जो अभी वेट्स मिले हुए दिस वेट्स बस उसे हमको ऐड करना है ये वाले वेट्स द इनिशियल वेट्स से हमको ऐड करना है यू विल गेट द न्यू अपडेटेड वेट्स दैट इज V11 न्यू इज इक्वल्स टू V1 ओल्ड प्लस V11 ठीक है ये कॉपी करो Have you understood this problem? Is it clear? Can you solve such type of problem? See, only 3 to 4 steps are important. First, आपको initial weight find करना है. Then net input calculate करो. उसके बाद activation function calculate करो. Then you need to find out the error between the input and the hidden layer, and then the change in the weights. Okay, so these steps are important to find out the back propagation problem. Done with this problem?
Yes, ma'am.
Okay, we'll see the next problem. This is also the similar one.
Ma'am, for how many marks this sums usually come?
This will be a problem of 10 marks, and this is one of the important problems. Back propagation का एक आएगा ही. Can you see the next problem? Now, can you tell me the initial weights for Z1 and Z2? Now यहाँ पे क्या दिया है? The input pattern consisting of -1 and +1. मीन्स इट्स सेम एज 0 and 1. ठीक है, सिर्फ यहाँ पे क्या है, बाइपोलर inputs दिए, that is -1 and +1, and the initial weights at Z1 and Z2. कौन बताएगा?
Ma'am, for
At Z1.
Z1 it is for Z1 it is minus
Yes,
0.4.
yes. Z1 it's minus 0.4. No, Z1 के लिए the initial weights, that is
Yes, ma'am,
V11,
it is minus
V21 and V01. Yes, it's 0.6, -0.1 and 0.3. Can you see this three arrows? V11, V21 and V01. So it's 0.6, -0.1 and 0.3. Now for Z2, it's V12, V22 and V02. So
1.2.
it's equal to, add नहीं करना है, it's not addition. You just need to perform it in vectorized form or to build it in vectorized form, जैसे हमने इसमें किया था. Initial weights for Z1 and Z2. So what are the weights? सिर्फ weights लिखना है, उसको addition या subtraction नहीं करना है. ठीक है, तो इसके लिए हमने initial weights define किया था V11, V21 and V01 as like this. We have kept it in vectorized form like this. Okay, तो similarly ये problem के लिए भी same ही करना है. We need to keep it in vectorized form only. उसमें addition और subtraction नहीं करना है. Okay, तो सबसे पहले we need to define the initial weights for this Z1, Z2, and then their initial weights for Y input. ठीक है, इनिशियल वेट जैसे डिफाइन करोगे उसके बाद हमको यूज करना है बाइपोलर सिग्मोइडल एक्टिवेशन फंक्शन. ठीक है, बाइपोलर सिग्मोइडल एक्टिवेशन फंक्शन मीन्स व्हाट? This one, 2 upon 1 plus e raised to power minus x
Ma'am, can
minus
you just
1.
show the figure once? I was actually copying it.
Yes, yes. Just write this down. आप लोग ये घर पे करके देखो. इसमें भी सेम स्टेप्स फॉलो करो जो आपने इसके प्रीवियस के लिए किया था. में सिग्मोइडल फंक्शन एक्टिवेट फंक्शन यूज करना है 1 minus e raised to power minus x upon 1 plus e raised to power minus x.
Ma'am, can you please share the PPT with us?
Yes, the first module की पीपीटी ऑलरेडी शेयर्ड, मैं ये अपडेटेड डाल देती हूँ फिर से। तो इसमें 2 मॉड्यूल कवर हो जाएंगे। ओके, फॉर द टर्म
Yes,
टेस्ट
ma'am. Thank you.
all 3 modules will be there। टर्म टेस्ट 1 के लिए 3 मॉड्यूल्स रहेंगे आपके इसमें, फर्स्ट, सेकंड एंड थर्ड।
मिस एनी आइडिया टर्म टेस्ट कभी शुरू होगा?
Yes, you are not audible।
मिस आई एम सेइंग दैट एनी आइडिया टर्म टेस्ट कभी शुरू होगा?
term test to last week of Feb। After DSC examination finish, your term test to schedule। ओके, तो अभी बहुत टाइम है, तो हमारा 3 मॉड्यूल कंप्लीट हो जाएगी तब तक। ओके, सो आई विल शेयर दिस पीपीटी और ये होमवर्क करो। tomorrow we'll discuss about if you are having any issues or problem, or else we'll start with the third module। Okay, I'll take your attendance, just a minute। Just a minute। Roll number 1, roll number 1 is there,
Yes, ma'am.
2, 3,
Yes, ma'am.
3, 4, 5,
Yes, ma'am.
5 is there, 6,
Yes, ma'am.
6, 6, 7, 7, 8,
Yes, ma'am.
9, 9, 10,
Yes, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
12, 13, 13 is there, 14, 15, 16, 16, 17, 18 is there,
Present, miss.
19, 20,
20 present, ma'am.
20, 20 is present, right? 21, Shravan Kumar, 22, 23, 24,
Present, ma'am.
20,
24.
24, 5, 26,
26 present.
26, 27,
Present, ma'am. 26.
28, 28 is there. 28, 28, 29,
Present, miss.
30, 31,
Present, ma'am.
32, 32, 33,
Present, ma'am.
34,
Yes, ma'am.
35, 35, 35 is there. 36,
36 present, ma'am.
37,
Present, ma'am.
38,
Present, ma'am.
38, 39,
Present, ma'am. Present, ma'am.
40, 40 is there. 40, 41,
Present, ma'am.
42, 42 is there. 43, 44,
Present, ma'am. 44.
45, 45, 46,
Present, ma'am.
47,
Present, ma'am. 47.
48, 48 is there. 48, 49, 50, 50 is there. 51, 51, 52,
52 present.
54, 53,
53, present, ma'am. 53,
54, 54 है. 55, 56, 57,
Present, ma'am. 57.
58, 57, 58, 59, 60,
60 present.
61,
present, ma'am.
61, 62,
Present, ma'am. 61.
61, 62, 63,
63, present, ma'am.
64, 64, 65, 66, 67, 68,
Present, ma'am. 68.
okay. 67 है क्या present?
67 नहीं है सर.
Okay. हाँ. Anybody left? Yes, anybody left? Okay, tomorrow we'll continue. Thank you. You can leave.
Thank you, ma'am. Bye.
Yeah, thanks.